Hey guys, let's discuss this probability problem. It's based on something called exchangeability and symmetry of random variables, and you will find this very exciting. Okay, so let's get started. So the problem asks the following, that if you have x1, x2, x3 and x4 as IID random variables, okay, with the distribution, let's say the density f of x, which is 1/4 if x is equal to -1, 3/4 if x is equal to 1, and 0 otherwise. What you have to find is, you find the probability x1 by x2 greater than x3 by x4. What is this? This is what you have to find. So, how to approach this problem? How to think about this problem? So the trick is, whenever you're given this IID with the same distribution, the idea that should come to your mind is something called symmetry or exchangeability. Okay, the idea that should come to your mind is symmetry or exchangeability. So what is that? Let me explain that. What exactly is it? Is this idea? The idea is this: that if you have n random variables, a joint random variable, and their IID. So if you have this n random variables, their IID, okay, with some distribution, let's say f, then if you take the distribution, this joint distribution of this n random variables, okay, if you take this joint distribution of n random variables, this is the same distributed as any permutation of this 1, 2, 3. Let's say 1, 2, 3 is changed to 3, 1, 2. So the joint distribution of x1, x2, x3 will be same as x3, x1, x2. Okay, the distribution is the same. So this is, mathematically speaking, this is same distributed as x of tau 1, x of tau 2, x of tau n. This is a permutation. So this is a permutation. I hope you're taking down notes. So this is helpful for your context building. Okay, I keep on saying this over and over again. Yeah, I mean, I myself make notes, so that's very important. Okay, so this is important. This is same distributed. So this is what the idea of exchangeability or symmetry is. Okay, so we'll apply this here, and we'll see how beautifully it solves this kind of problems. Okay, this is very important. This is a very important concept. So we are required to find probability x1 by x2 greater than x3 by x4. So if you think for some time, you will see that if you can permute, this will be kind of similar to, and we will do that math fully. Like if you, if you instead of this, if you do this, we will show that these two are equal. But more importantly, you can see that x1 has been transformed to x3, x2 has been transformed to x4, x3 has been transformed to x1, and x4 has been transformed to x2. Rather, the indices are permuted. The 1, 2, 3, 4 are permuted. So from that idea, you can kind of think that how can we integrate these two things together. And again, what we're doing here is we are dividing the sample space of these random variables in this following way. The sample space in this following way. Like let's call like either x1. So I mean I can write it fully mathematically, but then it will take a lot of time. But I am writing in the in a kind of hand waving manner. So the entire sample space is divided into this x1 by x2 greater than x3 by x4 plus the other way around. Plus what is left? Either they can be equal or greater than or less than, or they can be equal. Okay, and this consists of the entire sample space. Either two variables are greater than each other or less than each other or equal to. That consists of the entire sample space. You can easily write it mathematically, okay? It's very simple. Consider this as a random variable, consider this another random variable. So it will be x greater than y and x less than y and x is equal to y. This is the only possibilities. So this is the sample space. So the entire space can be broken into these three parts, disjoint parts. So by the law of probability, by the definition of probability, this sum should be 1 because it covers the entire sample space. Now the next step is, this is the first step. The next step is to show that these two are equal. Why are these two equal? Because we have an understanding that okay, if you replace, if you permute some of the indices, this term will look like this. So the goal is, by some permutation, this term will look like this. And by that permutation, so let's formalize that, okay? Let's formalize that if you transform this, if you permute this, then this will be the same probabilities. So how to do that? So here you start with x1, x2, x3, x4. So let's see now. How will this term look like this term, the expression? You can see that here, let's rewrite this as probability x3 by x4 greater than x1 by x2. Okay? So here, if you change it, so let's take the permutation. Let's take the permutation, which changes 1, 2, 3, 4 to 1, 2, 3 to 1 is going to 3, 2 is going to 4, 3 is going to 1, and 4 is going to 2. So if we take this permutation, okay, then by the exchangeability idea, x1, x2, x3, x4 is similarly distributed as x3, x2, x3, x4, comma x1, x2. The distribution is the same. Okay, by the theorem of exchangeability theorem, the symmetry theorem. So since the distribution is same, a subset, a property of the distribution, is a probability is a property of the distribution, right? Because probabilities are derived from the CDF, which are the distribution, cumulative distribution function. So the probability of, therefore, this. See, usually people skip this. Okay, usually people skip this analysis that they are symmetric and they will be equal. But I think it's very important to do this analysis. That what is the permutation for which often subtle issues can happen, and that can be a big issue. For example, if it was greater than equal to, then it will not be happening. Okay, it will not be. It will not be symmetric because it will be, the disjoint will be different. So we have to distribute it properly and make sure the symmetric property is formulated using an actual realized permutation. So this is nothing but probability x3, which we are required to find out, right? Let's call it lambda or x. Whatever we don't know is x. right? So what we get here is, so let me write it down. The number 4 is, since these two are equal, we get this plus this is equal to 1. So 2x plus probability x1 by x2 is equal to x3 by x4 is equal to 1, right? So we can take it on the other hand side to write that x is equal to 1 minus probability x1 by x2 is equal to x3 by x4 by 2. So therefore x can be represented in this probability term. So let's write it down. Let's rub it off. So I hope you have taken down the notes. It's recording, right? Yes, it's recording. Oops. This is what happens when you wear black trousers and you work with chalks. So, okay. So we have realized that this is what we need to find. Let's call it lambda and x. And x is nothing but, this is nothing but 1 minus probability x1 by x2 is equal to x3 by x4 whole divided by 2. Okay? So we need to find this probability. Now, given that this is a PMF, it's pretty easy to find because there are finite number of options x1 and x2 and x3 and x4 can take. So we need to find this probability x1 by x2 is equal to x3 by x4, which is equivalent to saying this probability is same as saying we cross multiply. Why will we just do? Because we are used to more multiplication than division. x3, x2. So we want to find this probability. So what we will do is we want to find this probability and we will just calculate its PMF. So let's calculate the PMF of just one of them. Again, since it's symmetric, since it's disjoint, both the distribution will be the same. You can prove it again in the same manner. You call this x, you call this y, and you can prove similarly that x and y are distributed. So if you find one PMF, you can automatically find the other. Okay? But here again, it's good to think about what permutation you're thinking of in this time. For example, 1 is going to 3 and 4 is going to 2. These things must be very clear. Observe that also this is independent of this. Okay? That also is important because all of them are independent. So this idea and play of independence is very, very crucial for this kind of problem solving. And it's very beautiful too. So let's find out the distribution of f of x1, x4 of x. So as you can see, okay, let's make it easier. So x1 times x4, so each x takes minus 1 and 1. So their product can either take 1 or minus 1, okay? Right? So therefore this can either take 1 or minus 1. So this is equal to 1 is same as saying that both of them are individually 1 or both of them are individually minus 1. Or, now exhaustive, so we are adding okay, and they're independent, so this disjoint will be divided into product of its marginals. Once you get this, you can now put the values out here. So you will get that both are 1, that is 3 by 4 whole square, both are the same. So 3 by 4 whole square is 9 by 16 plus both of them are 1 by 4, so 1 by 16. So 10 by 16. So this is the probability of this is equal to 1. Okay, so I'm rubbing it off. Oops. It's 10 by 16. And therefore, x1 times x4 is equal to minus 1 will be 1 minus this. So it will be 6 by 16. Okay. So we have got the entire distribution of this, and same for that. So let's call this A and let's call this B. Probability of A equal to B. So we have to find probability of A equal to B. And A and B are following the distribution. Both A and B. So probability of A and B, again A and B are taking either 1 or minus 1. So probability of A and B are equal is same as probability A equal to B equal to 1. So either both of them are equal or both of them are equal and 1, both of them are equal and minus 1. Okay? Very simple. So therefore, we again observe that A is consisting of x1 and x4 and B is consisting of 2 and 3, and both are independent. So this individually is independent, this individually is independent of each other. Okay? So we get, therefore it's independent, so we can do the same thing. Probability A is equal to 1 times probability B equal to 1. Probability A is equal to minus 1 times probability B equal to minus 1. So therefore we get 10 by 16 whole square plus 6 by 16 whole square. Okay? And if you replace it, the 4 will cancel out. So you will get 25 by 16 times 16 by 4. So 16 times 4, 64. Plus here 9 by 64. The 2 will go 4 and 16. So great. So we get 34 by 64. Great. So we have got 34 by 64. This is A equal to B essentially. This one is this. So therefore X probability of x1 by x2 greater than x3 by x4 is nothing but 1 minus this 34 by 64 by 4, 64 divided by 2. So it will be 30 by 64 by 2 is 15 by 64. So this has been, I worked the entire thing out because many students are watching this. If you think, you can really go from one step to the other, then fasten it up, watch it at a higher speed, but I want to reach out to more students who can do probability, do mathematics for AI and Quant. If you're enjoying this video, if you enjoy this video, do share your support. I will see you in the next video. Bye-bye.